Okay, today we are covering how to find the slope and the y-intercept from equations in slope-intercept form, as well as how to graph so-called equations as well. So we look here, we know slope-intercept form is y equals mx plus b, with our m being the slope and our b being the y-intercept. So knowing that information, we should be able to tell what A, B, and C are. So the directions say find the slope and the y-intercept of each linear equation. For part A, our slope, well, if we look here, m is our slope. So in this situation, whatever is attached to the x, in this case it's 3, is our slope. So we know m, which is our slope, equals 3. Okay, and we know b, which is the whole number right here, all alone, is a -4. So our y-intercept is a -4. Okay, we go over to b. We just have y equals 6.5. Now, it is in slope-intercept form because the y is by itself. We just do not have an x, which that tells us we don't have a slope. The thing that is only present here is our y-intercept because there's no x on it. So, in this situation, we have a y-intercept of 6.5, and our slope, since it's not there, is going to be 0. Okay, now we look at C. We know C is going to be in what we call standard form. We talked about standard form a little bit earlier. Standard form is when the x and the y are on the same side. That's pretty much what it is. So in this situation, in order to find our slope, we have to be able to get y by itself like slope-intercept form. We could find our y-intercept from standard form if we decided to put 0 in for x. We have negative y equals -2, which then in turn would tell us our y-intercept is 2. But since we don't have the slope in that form, we're going to knock 2 birds out with 1 stone, convert to slope-intercept form, because the only way to find slope in this situation is making it y equals mx plus b. So let's get that y by itself. The first thing we have to do is add 5x. That cancels it out. We move the 5x to the other side. We are left with negative y equals 5x minus 2. Now some of you might think that we're going to add the 5 and the -2. We can't because the -2 does not have an x. So now we're left with negative y equals -5 minus 2. In this situation, there's no number on the y, except we do have that negative sign, which tells us there's a -1. That y is not by itself yet, so we have to get rid of it by dividing by a -1. We know that negative y divided by a -1 is a positive y. That's what we want. Okay, and 5 divided by a -1 is a -5x, and -2 divided by a -1 is a positive 2. So this is our new equation in slope-intercept form. That's what we're looking for. Now, how do we find our slope and our y-intercept? Well, it's as simple as that. We got mx and we got b. Here our m is -5, so our slope is a -5. And our b is 2, so that means our y-intercept is 2. So simple as that. Once we get into that slope-intercept form, we're able to identify the slope and the y-intercept as well. Okay, up next is a monitoring progress. Go ahead and try this monitoring progress by yourself. Pause the video, try it. Let's get out of this. Pause the video, try it, check your answers when I'm checking. Okay, hopefully you guys have already done this. We know that number 6 was in standard form, and in order to find the slope, we need to just convert it to slope-intercept form. We start by subtracting the 6x. Get rid of it. We are left with 4y equals -6x plus 24. Okay, then we needed to divide our 4, which gives us y equals, now we're looking at -6 and 4. You can either put it in decimal form, or you can put it as an improper fraction. You could get negative 1.5. In my opinion, I prefer an improper fraction because when we graph slope-intercept form, having a fraction is much, much easier to work with. So we know we have negative 6 over 4. We divide them both by 2. That gives us negative 3 over 2x plus 24 divided by 4 is 6. So that is our new equation. Now all we have to do is identify the slope and the y-intercept. So we look here. M is going to be what's attached to x. We have negative 3 over 2. Our y-intercept is going to be the lone standing whole number, which is 6. So our y-intercept is 6. Okay, go ahead and check yourself. I'm going to erase this so I can move on to 7. Okay, we look at 7, it's already in slope-intercept form. We have m equals whatever's attached to x, which is negative 3/4. One thing I want to highlight here is our slope is negative 3/4. It is not negative 3/4 x. Do not include that x with your slope. If you do, I'm going to count it wrong. Okay, then we look at our y-intercept. The only thing that's really left is that whole number, and it's 2. Pretty simple, right? And finally, move over to 8. We have y equals 5x. It is in slope-intercept form because that y is by itself. We know that our slope is attached to the x, so our slope is 5. Our y-intercept, there's no y-intercept, is non-existent, so we're going to say it's 0. Okay. By now, you should be able to identify slope and the y-intercept from equations. If not, and you're still struggling, please send me an email or talk to me in class. All right, moving on. We're going to move on to graphing. Okay, this one says graph 2x plus y equals 2 and identify the x-intercept. Okay, this situation, we have two options. The first option is going to be A, we can graph with standard form, which in my opinion, when it's in standard form, and we have an even number there, it's probably going to be easier than slope-intercept form. But I'm going to show you slope-intercept form because if there's a equation already in slope-intercept form, like number 9 down here that you're going to have to do, then it's going to be easier after you know how to graph it in slope-intercept form. So we're going to convert this standard form equation to slope-intercept form. We subtract our 2x. Our new equation is y equals a negative 2x plus 2. Y is by itself, that's all we have to do. Okay, according to this right here, we have what we need. We have a slope of negative 2 and we have a y-intercept of 2. Since we have our y-intercept of 2, the y-intercept is where our line crosses the y-axis. So that tells us that our y-intercept of positive 2, we go up to 2 and make our first point because we know our line is going to cross either direction through that point on the y-axis. Okay, secondly is our slope. Our slope is a negative 2. Now, graphing purposes, it's going to be easier if we make that negative 2 a negative 2 over 1. Now remember, every whole number does have a 1 on the bottom. We just don't really use it that often, but in slope we're going to. If you have a whole number, it is always over 1 every single time. One more thing I want to say. We have a negative slope. In my opinion, it is easier to just keep the top number negative and make the bottom number positive. And the reason I say that is if we make both the top and bottom negative, we're going to end up over here causing our line to be a positive slope. So what we're going to do is we're going to use our rise over our run. Our rise is a negative 2. We have to start from our y-intercept, not from 0. So our rise is negative 2. We go down 2, 1, 2. Our run is a positive 1. We go over 1. Those are our 2 points. That's our graph. Now, the last thing it's asking, it's telling us identify the x-intercept. Just like the y-intercept, the x-intercept is where it crosses the x-axis and y is 0. It looks like it crosses the x-axis right about there. Our x-intercept is a positive 1. So that's how you convert from standard form to slope-intercept form, and then graph it. Now, the other way that we could graph, which might be easier, is just using standard form, using what we have. And we know to find the x-intercept, y needs to disappear. So we have 2x equals 2. To find our y-intercept, x needs to disappear. So we have y equals 2. We get both of these from the same equation. 2x equals 2. All we have to do is divide by 2 to get our x-intercept of 1. Now, for y, it's already solved for us. Our y-intercept is 2. So that's why in this situation, it's going to be much easier, especially when we have just a single y or a single x, to graph using standard form instead. Our y-intercept of 2 tells us it's crossing the y-axis at 2. Our x-intercept at 1 tells us it's crossing the x-axis at 1. We connect those two dots, and we already know our x-intercept. We found it using that formula. So in my opinion, when it's already in standard form, using standard form is probably going to be easier when it comes to graphing. Now, if I tell you, let's convert this to slope-intercept form, you're going to have to convert it. But if I just say graph the equation, you get to choose. Do you want to use standard form and graph, or do you want to use slope-intercept form? Okay, the last monitoring progress. Oops, don't want to move that. Okay, go ahead and pause the video. Obviously, we can see that number 9 is in slope-intercept form, so you have to graph it using slope-intercept form. And these two are in standard form, so you kind of get to choose what you want to do. So go ahead and pause the video real quick. Try them out on your own. And I'm going to go over both standard and slope-intercept form. Okay, hopefully you are done. Number 9 is in slope-intercept form. It is in y equals mx plus b form, right? Our y-intercept starts at a -4. And our slope is 4, which we know is 4 over 1. That means from this point, we go up 4 and over 1. And our graph is completed. With our x-intercept being at 1. So we graphed it, found our x-intercept, just like that. Now we go to 10. We have two options. We either do slope-intercept form or standard form. I'm going to do standard form just because I see this y by itself. I know that if I split them up into 3x equals a -3 and y equals a -3, I know that we already have our y-intercept. And to find our x-intercept, all we have to do is divide by 3. We have x at a -1. So our x-intercept is at a -1. That's where it's crossing the x-axis. Our y-intercept is at a -3, which is where it's crossing the y-axis. And that is our graph. Now, if you have to convert it back to slope-intercept form, we're going to cover that real quick. But we do know our x-intercept is crossing at -1. And that's what we want. Now, let's do slope-intercept form. Okay. Your teacher or your directions ask, convert that to slope-intercept form, then graph it. Okay, so all we have to do is get the y by itself. We subtract 3x, we have y equals a -3x minus 3. Y is by itself, it's in slope-intercept form. Our y-intercept is always the whole number. It's a -3. Okay, our slope is always next to the x, which is a -3. And we put all whole numbers over 1 when we're graphing slope. So from here, we can go down 3, 1, 2, 3, and over 1. Now, if you don't want to use a ruler, I'm not going to make you use a ruler to draw a straight line to see where our x-intercept is. What we can do is we can start at our y-intercept and use the opposite slope. We went down 3 and right 1. All we have to do instead is go up 3 and left 1. That's the exact opposite of what we did. It stays in our line. We don't have to use a ruler. And then all of a sudden we have our x-intercept. As long as you can identify your x-intercept, that's all I really care about. And as long as you can get your y-intercept and your slope correct. I don't care how straight your line is. You can make a line as straight as you want by making a dot, 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 dot if you really want to. Or if you want to use a ruler, that's completely up to you as well. In this situation, we see that our x-intercept is a -1. Okay, of course, like I said, if you have any questions, please let me know. Email me, ask me in class. We're going to do our final one now, and I'm going to do both the standard form and the slope-intercept form again. So let's start with standard form. Let's split them up. We have x equals 6, and we have 2y equals 6. As you can see, with standard form, all we did was we took the y out, made a new equation, then we took the x out, made a new equation, so we can find our x and y intercepts. So we know our x-intercept is already 6. Our y-intercept, all we have to do is get y alone. Y equals 3. So we have both of our intercepts. We know it crosses the y-axis at 3. We know it crosses the x-axis at 6. And that is a much quicker way to do things, right? Graphing in standard form when it's already in standard form, most of the time, I'd say 85% of the time is what you want to do, unless you have to identify the slope, which technically you could count and reduce to find the slope if you really wanted to. Okay, now, like I said, if you are forced to convert this back to slope-intercept form, which is y equals mx plus b, we have to get our y by itself by subtracting our x, which gives us 2y equals a -x plus 6. We talked about this a little bit earlier when we divide by our 2. Let me change colors here. When we divide by our 2, that -x is always 1. We're going to change that to a -1/2 x. 6 divided by 2 is 3. That is our new equation for this graph. Now let's graph it. Our y-intercept is always the whole number alone. That is at 3. Okay, our x, or our slope, is -1/2, which tells us we need to go down 1, right 2, make a point. Now, we still don't have our x-intercept yet, but what we can do to guarantee it without using a ruler and without trying to draw a straight line is we can just use that slope again, down 2/1. We're still not there. We still don't know our guaranteed landing spot on the x-axis, so we got to do it one more time, down 1/2. Now, all of a sudden, we have the exact same line as what we did with standard form, and we know our x-intercept is landing at 6. So, I've gone over 2 different ways. When you have an equation in standard form, 2 different ways that you can use to solve or to graph. You can either A, keep it in standard form and graph it using the intercepts, or B, you can convert it to slope-intercept form and graph it that way. Choose which one you like better. You might like slope-intercept better. You might like standard form better. But of course, if you end up with something like this, you have to use slope-intercept form. Converting it back to standard form, it would work. It's added work, I guess, in my opinion. So